Hello and welcome. Okay, in this video we're going to be tackling the third question of June 2014 in Cameroon DC. If you're not following the beginning of this series, make sure you check out our video, and we are actually solving GC past question papers from 2011 to 2021, so as to touch as many questions and cover a lot on what we have covered so far in our channel, on this channel. So this question here, which you see on your screen, reads: the root of the quadratic equation x squared minus x plus 2 equals to 0 are alpha and beta. Prove that a 1 divided by 1 plus alpha squared plus 1 divided by 1 plus beta squared is equals to negative half, and b 1 divided by 1 plus alpha squared times 1 divided by 1 plus beta squared is equals to half. So the product of the first one is negative half and the second one is half. So we actually face similar problems like this one. So I'll suggest that you take a pen and paper and give it a try. The only thing that changes here are the roots, the new root of the quadratic equation which are given to you, and in this case which are the roots you're seeing in the question. So let's dive head first on this problem. Now we begin with the initial root that we have. Okay, so we know that with alpha and beta as roots, sum of roots, which is alpha plus beta, is equals to negative b on a. Okay, and from our equation, here, negative b has a value of negative 1, so negative b is going to be equal to 1. Okay, so we're going to have 1 divided by 1, which is negative b on a, and this is equals to 1, and product of root alpha beta is equals to c on a. Okay, this is equal to c on a, and c has a value of 2 divided by 1, which is equal to 2. Now we have the sum of roots. We can now derive the sum of new root and the product of new root. Now for the sum of new root and the product of new root, we're making use of the roots we are given in the question. So I'm going to go ahead, sum of new roots, which in this case is going to be 1 on 1 plus alpha squared plus 1 on 1 plus beta squared. Okay, taking care of the LCM, this is going to be equals to alpha squared plus beta squared plus 2 equal to 1 plus alpha squared plus beta squared plus alpha beta squared. Now we're going to make use of an identity here, which I'll leave the link of the video in the end, either in the end screen or in the description. Make sure you check it out. So it's about this guy here, because actually we don't have any identity for alpha squared plus beta squared, but we do have for alpha plus beta. Okay, but now do not forget that alpha plus beta can be squared, and when you squared, you get alpha squared plus beta squared in that result. So you could simply mix up the formula. So you could check it out the video and try to understand how to derive the other identity as well, so you can get familiar with this particular problem. So moving forward, we're gonna have our sum of new roots equal to, now, and this, the identity of alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. So make sure, if you don't know how to get this identity, make sure you check the video and get back to this one. And all this plus 2 divided by 1 plus alpha plus beta all squared minus 2 alpha beta plus alpha beta all squared. This is equal to, okay, alpha plus beta has a value of 1 and alpha beta has a value of 2. Multiplying it by 2 gives you 4 minus 4 plus 2 divided by 1 plus 1 squared minus 4 plus 4. Okay, and this is equal to, now doing the operation on the numerator will give us a value of -1, and on the denominator a value of 2. So this proves that we have actually this proves the condition specifying part A. Now for the B part of this question, we're indirectly looking for the sum of new roots. And again, I forgot something. There's another part of this question which said that you have to form a new quadratic equation, and this is the part of B. So here we have 1 on 1 plus alpha squared times 1 on 1 plus beta squared, sorry, not alpha. And this is going to be equals to 1 divided by 1 plus alpha squared plus beta squared plus alpha beta squared. We already know the value of this from the previous problem, which is a 2, and is equals to 1 on 2, because we'll simply have a 1 in the numerator. Okay, so these two satisfy, shows that we prove the problem. And to show that you have arrived at a conclusion, you can simply show the write this beside your answer, QED. So you do same here. Okay, so now the last part of the B equations asks us form a new quadratic equation, and we know the formula from the previous example, or from your textbook, which state that a new quadratic equation is given by x squared minus sum of new roots and x plus product of new roots. So for this equation here, we're going to have x squared plus, because negative times negative will give you plus, and because the value was negative, half x on 2 plus half equal to 0. And this implies that the equation is 2x squared plus x plus 1 is equal to 0. Okay guys, that's all for today. See you in the next video.